Today we're going to be talking about basic atomic structure, chiefly what atoms are made of and how that relates to ions. We are going to do this by looking at our subatomic particles. Subatomic particles are exactly what they sound like, the tiny little particles that are in each and every atom. These subatomic particles are important because they are what make each atom different and unique. The first two particles are protons and neutrons. Each of these two particles account for the mass of an atom and reside in the nucleus of the atom. Protons have a charge of 1 plus, and neutrons have no charge. They are neutral. Knowing how many protons are in an element is a very simple process. You look at the periodic table and find the element. Here we will use carbon. The atomic number, which is located at the top of the element square, tells us how many protons there are. So carbon has 6 protons. Gallium, element number 31, has 31 protons. All atoms of an element, even all the various ions, have the same number of protons. Knowing how many protons are in an atom, we can calculate how many neutrons are in the atom. We will use our carbon square again to see this. The neutrons and protons of an atom together equal the atomic mass of the element. The atomic mass of carbon is 12, so we must have 6 neutrons to add to the 6 protons to equal the mass of 12. The neutrons and protons of an element do not always equal each other. So that leaves the third subatomic particle, which does not hang out in the nucleus with the others. The final particle is the electron. Electrons are different than neutrons and protons in that they don't have any measurable mass. You can think of electrons as the opposite of protons because they have a negative charge. When the charges of the protons and electrons are added together, that gives us the charge of the overall atom or ion. Electrons, unlike protons and neutrons, don't have a definite home. The electrons float around or continuously move throughout the atom's electron cloud. This is the area outside of the nucleus. How far away from the nucleus the electrons can go is a matter of intermolecular forces. These electrons that are moving around outside the nucleus is how we get our ions, or charged particles. Ions are really just atoms with a charge. The electrons of atoms are capable of moving from one atom to another, or they can be shared. This means that while the number of protons and neutrons of an atom doesn't change, the atom can gain or lose an electron to form an ion. Since all atoms start with the same number of protons and electrons, they have a charge of 0. If an element loses an electron, it becomes positive and a cation is formed. Likewise, if an atom gains an electron, the charge will be negative, forming an anion. Now let's look at an example to put it all together. We'll look at an atom of silver 1 plus. In order to find out how many of each of the subatomic particles are present, we will need our periodic table. So let's go to the silver square. We'll start with protons because those are the easiest. Silver is element number 47, so silver has 47 protons. Using the silver ion, which has a charge of 1 plus, we can calculate the number of electrons. Each electron has a negative charge of 1. And the silver ion has a positive charge of 1, so clearly silver must have lost one of its electrons. That gives us 46 electrons and 47 protons. To calculate the number of neutrons, we need our atomic mass number. Since it has a decimal, we will round. In this case, we will round up to 108. Protons and neutrons combined give us our weight, so to solve for neutrons, we will subtract protons from the weight. 108 minus 47 equals 61. So there are 61 neutrons in silver 1 plus to go along with the 40